Hello friends, I hope you will be doing good and preparing well for the exam. This is Dr. Muhammad Umar, Assistant Professor from Department of Civil Engineering, and today I came up with a new topic on friction, which is nothing but ladder sums made easy. It has two parts, so we'll see part 1 in this video. So what we are going to see in this video, we'll see the steps to solve ladder sums. Then we'll see or we'll learn about the tricks to solve ladder sums, and we'll solve an example. We'll see how we can solve it easily with the help of these steps and tricks. So let us see the steps first. So first we need to draw the free body diagram. That is very important. To solve any sum in friction, you need to draw the free body diagram. And how you are going to draw the free body diagram of a ladder sum. Okay, so it is different from the block sum. So let us see the block sum first, okay, and then we'll see the ladder sum. What is the difference in these two? Okay, so let us have a block here which is resting on the ground. Okay, so the weight of the block will always act at the centroid or center of gravity of the block, which is nothing but at the center, geometric center of the block, which will always act downward. And since this block is in equilibrium, to balance this will have a force which is normal force and which will always act perpendicular to the surface. Okay, now if suppose we'll have a force P which is acting or pulling the block, and if the block its surface is rough, then we'll have a frictional force which will act opposite to the direction of motion always. Okay, so this is a general free body diagram. If suppose this surface is smooth, then you will not have any friction. Okay, so you will always only have these three reactions. Okay, this is the general free body diagram for a block sum. Okay, but in the case of ladder sum, you will have the weight of the ladder which will be acting at the center of gravity of the ladder, and here we have, in the case of block sum, we have single support, but in the case of ladder we have two supports. Okay, so one is at A and one is at B, so hence we have two normal reactions. Okay, one is at A, which is nothing but Na, and one is at B, which is nothing but Nb. Now one thing we need to keep in mind, that normal force will always act perpendicular to the surface. So here the surface is horizontal and hence the normal force is vertical. Here the surface is vertical and hence the normal force is horizontal. Okay, now this ladder at point B will try to move downward, and hence your frictional force will always act opposite to the direction of motion, and this will act upward. Here at point A, this ladder will try to move outside, okay, towards left, and hence the frictional force will act towards the right. This is the free body diagram of a ladder. So this is, if you are drawing with this, you can easily able to solve the ladder sum. Apart from this, in the question they have given anything extra that you can add, but this is only the free body diagram of a ladder sum. Okay, now the second thing is that you need to learn basics of trigonometry. You need to know that. Okay, so what is that? That's very easy. Okay, that's some of the standard. Okay, one is this, suppose you have a right angle triangle over here. So what is sine theta? It is nothing but opposite by hypotenuse, which is nothing but, you can write it as P by H. If suppose this is P and this is H and this is B. Okay, so if you wanted to know P, we can write it as H sine theta. Similarly, cos theta can be adjacent by hypotenuse, so this we can write it as B by H. Okay, so if you wanted to know B, we can write it as H cos theta. Agree? Okay, so this is what you need to know. Okay, the third thing is you need to know the conditions of equilibrium for the ladder sum, okay, or for a 2D problems. So now first is sigma fx equals to 0 means summation of all the horizontal forces acting is equals to 0. Sigma fy means summation of all the vertical forces acting equals to 0, and summation of moment at any support is equals to 0. Now here you have to understand that at any support, okay, which means that here we have support A and we have support B. Okay, so moment will be 0 either at A or at B. Okay, it will not be 0 at this point. Suppose this is C, it will not be 0 at C. Okay, so this you have to keep in mind, okay, or take care during solving the sum. Okay, so let us now see the tricks. Okay, so that first trick is that the direction of friction force will always be opposite to the sliding per motion. Okay, so that you should remember. Okay, the normal force will always perpendicular to the surface. Okay, that we have already discussed. Okay, so it will always be perpendicular to the surface as we have seen in this case. Okay, and the weight of the ladder will act at the centroid of the ladder. Okay, so it will always act at the center of the ladder. Okay, so okay, so we'll move further and now we'll see the sum. So the sum, it says that a uniform ladder of 3 meter long. Okay, so this ladder is 3 meter long, weigh 200 Newton, and this weigh is 200 Newton, which is acting at the center of the ladder. It is placed against a wall making an angle 60 degree with the floor. So this is making an angle 60 degree with the floor. Okay, so here we have this 60 degree with the floor. Okay, the coefficient of friction between the wall and the ladder, is 0.25, which is 0.25, which is mu c. In this case we have it is mu c, and between the floor and the ladder is 0.5. So this is 0.5. Okay, the ladder, in addition to its own weight, this is additional they have given. Okay, so that the ladder addition to its own weight has to support a man weighing 1 kilonewton at the top. Okay, so a 1 kilonewton force, this is 1 kilonewton force is acting at the top, means at point C, and the load will act downward. Since it is a weight, this will always act downward. So what we have to find, we need to find the horizontal force P, a horizontal force P to be applied to the ladder at the floor level, to prevent slipping. Okay, so this they have given extra. You need to find this force P, to prevent the slipping of the ladder. Okay, so let us start solving the sum by applying the first condition. What is the first condition we need to do? The first condition is to apply the to draw the free body diagram. Okay, so we'll draw the free body diagram of this ladder sum. Okay, so first we have done this 1.5 meters to show that this load is exactly acting at the center. Now we'll draw the normal forces. Okay, so this NC is acting perpendicular to BC and NA is acting perpendicular to AB, surface AB. Okay, now frictional force FC is acting opposite to the direction of sliding of at point C of the ladder, and frictional force FA is acting opposite to the direction of sliding of ladder at point A. So this is all about the free body diagram. Okay, this is all you have to do. Okay, next you have to apply the basics of trigonometry to find some of the basic dimensions like BC, AB, AD, which will be helpful for you to solve the sum. Okay, so that I am going to find it now. So let us find AB first. Okay, so what is AB here? AB is adjacent. Okay, so we can apply this formula, adjacent by hypotenuse. Okay, cos theta. So we need AB, so we can write it as H cos theta. Okay, and here H we have 3 meter for the bigger triangle A, B and C. So we'll get the value of AB, this is 3, and theta is 60 degree. So we'll get the value of AB as 1.5 meter. If you'll solve, you'll get the value of AB as 1.5 meter. Okay, now we'll apply. Now we'll find BC. Now we'll find BC. Okay, so BC is perpendicular. Here BC is perpendicular means opposite. So here opposite by hypotenuse. Okay, here this. So this formula we can apply. So which is nothing but H sine theta. Okay, so H is 3 in our case and theta is 60 degree. So we'll get the value of BC as 2.598 meter. Okay, we'll get the value of BC as 2.598 meter. Okay, now we can also find AD. So this AD can be found with the help of this small triangle AD, and you can take this as E. Okay, so we need AD, which is nothing but adjacent. So again we can apply the formula of cos theta. Okay, for the smaller triangle AD is H cos theta. Here for this case H is this smaller one. Okay, since the small triangles will have H as 1.5 meter, so we'll have H as 1.5 meter in this case, and theta is 60 degree again. So this will be 0.75 meter. So we got the 3 required dimensions which will be helpful for us to solve the sum. Okay, so let us move further. Now we have applied the first step, which is drawing the free body diagram. Then we applied the second step, means basics of trigonometry, to find these values. Okay, and now we'll apply the third step, which is nothing but equilibrium conditions. So in this we'll have first condition as sigma fx is equals to 0, which is nothing but summation of all the horizontal forces acting on this ladder equals to 0. Now we'll assume the sign of convention. Okay, we'll assume that right side, the forces acting in the right towards right direction or pointing towards right direction is positive, and the forces pointing towards left direction is negative. Okay, so here we have horizontal forces as P, Fa and Nc. Okay, so with the help of sign of convention we'll just write it as P, since P is acting towards right, positive. Fa is acting towards right, it is also positive, and Nc is acting towards left, it is negative. This is going to be equals to 0. Okay, now we know that frictional force is nothing but mu into normal force, means coefficient of friction into normal force. If suppose it is acting at A, this will become mu A into Na. Similarly Fc is equals to, for Fc it will be mu C into Nc. Okay, so this we already know. So this value we can put, this formula, with the help of this formula we can put this over here. So now P will be equals to, here we will take all the things opposite other side of the equation. Okay, so Nc will become positive, Nc will become positive, this Fa will become negative, and Fa we can write it as mu A into Na. Okay, and again mu A we know. What is mu A? Mu A is 0.5. Okay, so we can just rub it and we can write mu A as 0.5. Okay, so here itself we can write it as 0.5. Okay, so this we can treat it as equation 1. Okay, now we can apply the second condition of equilibrium, which is nothing but sigma Fy is equals to 0. Here we'll assume the sign of convention as upward as positive and downward as negative. You can assume the otherwise also. Okay, but you should follow that. Now we have upward forces as N, or vertical forces as Na, 200, 1000 and Fc. Okay, so based on the sign of convention we'll just write it over here. So Na will be positive acting upward, and 200 will be negative acting downward, 1000 again will be negative acting downward, and Fc will be positive acting upward, and this total will be equals to 0. Okay, now we'll try to take this 200 and 1000 to the opposite other side of equation. Na we can write it as it is, and Fc we can write mu C into NC. Mu C is nothing but, here you have mu C as 0.25, so this will become 0.25 NC is equals to 200, means 1000 plus 200. Okay, so this will assume it as equation 2. Okay, now we'll apply the third condition of equilibrium, which is nothing but sigma m at any support is equals to 0. Now you have to take care of an important thing here in mind, that which point you should take at 0. Okay, so as we have discussed before, that it should be at any support. Okay, so it can be either at A or C, it cannot be at B. Okay, now which we should take? Okay, shall we take A or shall we go for C? How is there any trick to choose any support? Okay, yes, it is there. Okay, so what you have to see, that which support has the maximum number of reactions. We have a reaction P here, we have Na here, we have Fe here, 3 reactions here. Similarly, we have Fc here, we have Nc here, we have 1000 here. So we have 3 reactions at both the supports. So here we can choose any support. Okay, either support. But if suppose you have maximum reactions, means 3 here and 2 here, so you should choose support A if in any other problem. Okay, so let us choose support A here. Okay, so now this moment, summation moment at A is equals to 0, will assume the sign of convention as clockwise as positive, anti-clockwise as negative. Okay, now we'll take the moment about A, all the reactions of all moment, reactions of moment of all the reactions, sorry. So for this 200, because of this 200, it will cause a clockwise moment at A. Okay, so that's why it will be positive, therefore it will be positive. And now again you need to take one more important point here, that you have to take the perpendicular distance. So this is acting vertical, so you have to take this perpendicular horizontal distance AD, okay, to make it a moment. This is a force, you need to make it a moment to multiply it with perpendicular distance AD. Okay, so AD is 0.75 here, this is 0.75. okay, now the next force will take 1000, because this 1000 will cause clockwise moment at A, and hence this will also be positive. Okay, now this 1000 is again acting vertical, and hence will take the distance horizontal AB as the vertical distance. Okay, 1.5, which is nothing but ABS is equals to 1.5. we have already calculated this. Okay, now we'll take this NC. So NC will create an anti-clockwise moment at A, and hence this is going to be negative. Okay, or now, okay, please pay attention. So NC is acting horizontal, okay, and hence we'll take the vertical distance as the perpendicular distance, which is nothing but BC, and BC is 2.598. we have already calculated. So BC is 2.598. okay, again last is FC. okay, FC is again create an anti-clockwise moment at A. okay, so FC will again be negative. Okay, and here again FC is vertical, acting vertical, line of action is vertical, and hence you will take the vertical distance of FC as AB, which is nothing but 1.5, and this is going to be equals to 0. okay, now we'll solve this sum and we'll find the answers. Okay, so what we'll do, we'll take these two things to the other side of the equation to make it positive. So we'll have here 2.598 NC. okay, and this will become positive. FC we can write it as mu C into NC. So mu C is 0.25. okay, so 0.25 NC into 1.5 into 1.5, this will give me 1650. okay, if you solve this you will get 1650. okay, now next is, if you solve this one, you will get the final value as 2.973 NC. this is going to be equals to 1650. okay, so NC will be equals to 1650 divided by 2.973. This will give you the value as 554.994 Newton. Okay, got the value of NC. Okay, if we'll put this value, in equation 2, put the value of NC in equation 2, you'll get the value of Na as, if we'll solve this, you'll get the value of Na as 1061.251 Newton. Okay. Similarly, if we'll put the value of Na and Nc collectively in equation 1, we will get the value of P. So the value of P is equals to, if we'll solve it, you will get as 24.363. I hope you have understood this sum. If you have any doubts, you can always reach out to me. Have a wonderful day.